So I want to thank everyone for coming. First of all, it's the last day, the afternoon of the last day, and you've all resisted the temptation to get on a flight, go home early, or just not show up. So I appreciate it. I'm going to take the next 30 minutes or so of your time and talk about MySQL 5.1 in the context of data warehousing and business intelligence. You're all very familiar with MySQL in running behind the scenes on web applications, but I want to hopefully let you know that it can be used in more applications besides that. It also has some good uses in the data warehousing area. And to do that, I'm going to talk about 3 different use cases for MySQL 5.1. The first is going to be some analytic modules that we created at Breadboard BI, and they're actually free. You can download them and try them out, and they're on an open source license, so you can just take them and keep them and do whatever you want. The second use case is a use case in the data cloud, in the Amazon EC2 cloud, and that's a prototype that Breadboard did with a company called Good Data. We're going to talk a little bit about that as well. And then the last business case is project we did for a company called yachtworld.com and boats.com, and that's a more traditional data warehouse type project. And at the end, we should have plenty of time for questions and answers. So, brief introduction. I work for a company, as I now mentioned, called Breadboard BI. We're a small business intelligence company focusing on consulting services in Pleasanton, California. Our reach extends across the world for our partners. We have a partner in Australia, Belgium, Chile, Mexico, Portugal. We've been a MySQL partner since 2007. And as I mentioned, our first case, our use case study will be about the modules we created that are free. On the back end, they run MySQL 5.1. And on the ETL and the data presentation layer, they're running Pentaho's suite, all open source. So a few words about the analytic modules you can get from our website. They're grouped into 4 high-level functional areas. So we have Customer 360, Finance, Supply Chain, and Workforce. And under those solution areas, we call them, we have the actual modules themselves. If you're familiar with data warehousing, they're essentially individual data marts, but they run in a common back-end database. So the dimensions are all shared, conform dimensions. The fact tables are all compact with surrogate keys and that type of thing, all dimensionally modeled in a star schema. And underneath each area, we have very commonly found modules like clickstream, contact center marketing, returns, sales leads, sales opportunities, and sales orders. We have finance, accounts payable, accounts receivable, billing, budgeting, forecast, and ledger. And supply chain, traditional modules from requisition all the way through inventory. And then workforce, shift compensation, recruitment, and snapshot. And if you go to our website, you can actually see them, you can interact with them, and then send us an email, and we can send you whichever ones you want. They're going to be out on SourceForge probably in about 30 days, then you can self-service and get them whenever you'd like. And a few of our modules are available in Spanish, and it's not indicated here, but I think that 2 of them are in Chinese, and we also have 3 of them in Portuguese. So behind the scenes on these analytic modules is an enterprise data model, which is running on MySQL 5.1. We use conform dimension, fact, bridge, and tree tables, following a very traditional Ralph Kimball style of designing. So we have conform dimensions, fact tables, bridge tables, etc. There's very consistent naming conventions across the objects, and a lot of metadata within the thing. I want to just briefly show you the data model and show you some of the presentation layer objects, and then from there you can self-service on our website if you're interested. So we maintain the enterprise data model with a tool called Toad Data Modeler. As we have 23 modules, we have about 23 physical areas that you can click into. In this case, I've opened up Customer 360 returns, order returns area. So we have a traditional star schema here. So now it might look a little bit like a star. And this side is a fact table, and then there are conform dimensions around the fact table. And it's a pretty significant model as far as attribute-wise. It's fully attributed. There's a lot there. So you probably wouldn't need all the attributes, but as we do new projects and a new customer needs new columns, we add them in. So when you download it and use it, you can choose to use our customer dimension. You can hack out whatever you don't want, or you can just add your own columns. It's up to you. We hope that if you do add columns, you'll send them to us, and we can include them back in the main model. So when we design new dashboards, reports, they'll be in the next version. So, and I mentioned metadata. We do have a lot of metadata within the model. So all the tables are commented, all the attributes are commented in English. And some of them have expanded comments as well. Again, this is all running MySQL 5.1, all designed through MySQL. So that was the first, let me show you a couple of things. So if you come into our website, you can click on our demo. And from there, you can see some of the dashboards, reports, and cubes that come with the analytic modules. We're running on the community edition of Pentaho 2.0, so this is all, everything you see is free. You can download everything without, there's no licenses. So again, we have the 4 high-level areas: Customer 360, Finance, Supply Chain, Workforce. I'll just show you very briefly. Sales order module. So within each module on the presentation side, we have them broken down into 3 different types of objects: cubes, dashboards, and reports. So the cubes are basically OLAP cubes, which you can drill into. In this case, it's an order time analysis cube. And you can see we have the date time hierarchy here, which you can drill down. And we have measures at the top. You can continue drilling down until you find what you want to find, basically, on the cube. Aside from cubes, all our modules have dashboards. These are JSP-based dashboards, running against MySQL, of course, in the back end. Of course, during the presentation, it's always slow. No, this is that's in version 3. The community edition. No, these were built with just straight JSP that are referencing Pentaho's dashboard widgets. But once we go to 3.0, there will be. We'll start using the dashboard piece. But they're fairly heavily commented, the JSP pages, so it's pretty clear what's going on there. But of course, a lot of people don't want to get into JSP at all. So once we convert them, it'll be nicer, easier to use. So you can see we have basically a pretty traditional dashboard, completely drillable, and it just doesn't show up that great in this resolution, unfortunately. So anyway, moving right along. And then finally we have reports, but I'm sure everyone's comfortable with what those look like, so I'm just going to show this there. So that's the first use case of MySQL 5.1 in a business intelligence kind of paradigm. It's the free modules we offer. The second one that I think might be interesting for everyone is a prototype we did with a company called Good Data. Let's get this back. So Good Data is a company that it's a new company. They just relocated from the Czech Republic. Their headquarters are here now in California. And they're a software as a service business intelligence provider. So they use the term collaborative analytics to describe what they do. So you can take data, you can basically go to their website, sign up for free, and you can upload data files into their system. And then from Irish jig next door or something? Sorry. You can upload files into their system. And from there you can build reports and share those reports with other people who log into your project. So it's a pretty interesting free tool. I highly suggest you log in there and try it out sometime. You upload like a spreadsheet of data, with order data. You can create reports immediately. It's pretty nice. I think I mentioned all this. So what we want to do with Good Data, the idea of uploading your data manually is particularly practical for most applications. You want an automated system which pushes more than one file. You probably want to analyze many different dimensions and facts in your organization. You want that manually, maybe every night, or every 3 hours or 4 hours. You want data extracted from your source systems, and you want it loaded automatically into the good data database. So the prototype we developed was to extract data automatically from a customer site, push it into the data cloud, and then have good data tools available to users to create their own reports and share those reports, annotate those reports for other users. So that was the purpose. This is the model we came up with, the prototype model. So over on the left-hand side, we have the customer site. And we did a pretty low-power Windows box, a Dell E1800 server, running Windows 2003. And a pretty lightweight stack, honestly. We just have the JDK, Pentile data integration, and JEX 3T. JEX 3T was used to sync data from a local directory on this Windows server with a Amazon S3 bucket in the data cloud. So we use Pentile data integration to extract the data from the source systems and put it into files, which were then compressed, encrypted, and then pushed into the data cloud. Once in the data cloud, the data was basically in an S3 bucket, and we used Chrome to schedule more Pentile data integration jobs to extract the data from the data files and load a MySQL 5.1 database. In fact, it's the same database design I showed you briefly earlier. It's dimensions, fact tables, that type of thing. In the data cloud, we use a very small EC2 server, a small instance, CentOS, pretty lightweight JDK. Again, Pentile data integration, MySQL 5.1, S3 command, and S3 sync to manipulate the files in and out of the buckets.
Command and sync are your own tools, or?
No, those are open source tools you can download from Data Project, I think, on SourceForge. If you Google it, it'll come up. So once the data was in MySQL 5.1 in our database, we had to push it out somehow to good data. The way we did that was, again, to use Pentile data integration, push it into an S3 bucket, a customer-specific S3 bucket, because the customer security was extremely important to good data. Obviously, it would be a terrible thing if company X data got linked to company Y's, or company Y saw company X's data. So we pushed the data out to client-specific buckets, automatically set the ACLs, which are the permissions on the files, so that the good data Amazon S3 user could go in and get the data and automatically load the data into their MySQL databases. Any questions on the prototype? I think the important thing was it's a completely open source solution from the MySQL 5.1 to the Pentile data integration. Pretty small amounts of data. So data was in the thousands of rows per file instead of hundreds of thousands or millions, which you might encounter. Using thousands of rows, it was very quick. It was instantaneous. So pushing a lot of data into the data cloud, and you're hitting on a good point. It's not going to be for every implementation. If you're dealing with hundreds of millions of rows or millions of rows that you need pushed every night, you can't do smaller incrementals. It's probably not the way to go. But for a lot of data warehouses, they don't have that much data. Maybe the data is just spread across a lot of systems. So you're talking about hundreds of thousands of rows, which would work in this instance for sure. So a little bit more detail about the three pieces of the prototype. So on the customer side, on a scheduled basis, we extracted data from the source system. We loaded predefined stage files, compressed the files, and then transmitted them to the S3 using JEX 3T. Not very many required components. It was a single server running Pentile ETL. Our predefined ETL objects we created for our modules, we just had to change them a little bit. Zip to zip the files, and JEX 3T to sync the files with a bucket on Amazon. All these comments I hit over. And within the cloud, we have a single EC2 server. We got files from a single client-specific S3 bucket, decompress the files, extract extracted the data, put a lot of sophisticated transformation logic used on top of data integration. Intel ETL server, Breadboard BI, predefined ETL objects, we use zip, S3 command, S3 sync. You could also use GS3T. We didn't use that on the Linux server in the cloud. And then MySQL 5.1. MySQL 5.1 partitioned by customer. So that... Sure. In this case, for the prototype, one database, and each table was partitioned. There was a customer key in each of the tables. And so we had one database, but virtually had one database per customer.
Does that satisfy the requirements?
No, when we go to production with this, we'll probably use individual databases. It's very simple to turn on another EC2 instance, dedicate it to just one customer. And you can't mix the data, but for the prototype, we want us to do it this way. I wouldn't advise it in production. I have done something similar like that with Oracle, with BPD, a virtual private database, but again, in the cloud, it's so easy to spawn up another instance and just dedicate it to a customer that I don't think I would try that. So finally, the handoff to good data, and I should add that good data does not mix the data. They do use one database per customer. They don't combine it at all. They don't partition by customer. They have an individual MySQL database per customer for their production systems. I think I hit all these. So what do we learn? We can do it. That was the big question at the beginning, is what we're working on. We can take what we've already built and apply it in the cloud. We did find that it worked. Components were well suited that we've developed in the client-server kind of paradigm. They worked fine, with only minor changes. And most of the changes, things we had to learn were how to get data in and out of the cloud. So basically, how to manipulate data in the buckets, in S3 buckets, because you couldn't use the FTP protocol at that time. In the cloud. So you have good data maintained one database per customer in the cloud, and then they have their own presentation layer tools. People can go in and create their own report, share the reports, and that type of thing. So that's pretty common. We knew this going in, but the data cloud offers businesses a low cost, highly scalable alternative that can scale according to demand immediately. So you don't have to call down, order a server, wait for the server to be shipped, set it up into your server room, configure it all. You can automatically, basically clone existing servers on demand. You can do that automatically. So the final case study was the one that we actually advertised for this talk, and it's a project we did with Yachtworld and Boats.com. I'm not sure if there are any boaters in the audience, but if there are, you're probably familiar with Yachtworld and Boats.com. It's a very popular online sales channel for selling boats. Yachtworld focuses on yacht brokers, and Boats.com provides marketing and web services for new boat dealers, builders, and offers a pretty popular for sale by owner classified service. So if anybody wants to sell their boat, they can post their boat online, and hopefully they'll get multiple offers on it and get ready to boat. They do a pretty good volume, 140,000 new and used boat listings worldwide, offered by over 4,000 brokers, dealers, and builders in 115 countries. 4 million voting consumers every month. They click through about 95 million page views. And they're headquartered in Seattle. They have European offices, sales offices in different parts of Europe, and representation in China, Dubai, and Australia. And they're part of a common parent called Lavigne Enterprises based in North Virginia. So they wanted to build a business intelligence solution. They had a fairly small budget. They had a lot of data, pretty diverse data. So several different operational systems, several different types. So there were MySQL and there were Oracle databases. They had large amounts of data in Apache web server logs. Their boat listing inventory systems were in Oracle and MySQL. They also, aside from boat listings, they wanted to track email and toll-free calls to their affiliate broker dealers and builders. And again, those were in Oracle and MySQL. And a lot of supporting data in different flat file formats that you'd always find. spreadsheets and a binary database for GeoIP data. And so that was the challenge, different types of data, different systems they were in, and the budgetary constraints. So we opted to build a solution on an open source platform using Pentaho and MySQL 5.1. On the left-hand side, you can see the different types of systems we had to extract data from. So there were Oracle, MySQL, Apache logs from Boats.com, Apache logs from Yachtworld.com, miscellaneous data, GeoIP data, supplemental data, that type of thing. And pretty traditional data warehouse. We extracted data overnight, every day, using Pentaho data integration. And we chose MySQL 5.1, in large part because of the partitioning. We had a lot of data, very large amounts of data, and we needed to partition those tables. We'll talk a little bit more about that in the next slide. And to actually present the data to the users, we used Pentaho dashboards and Pentaho reports. So we came up with a solution which was 100% open source and still handled the large amounts of data that they had. A little bit more about the MySQL database layer. So we used the MyISAM and memory engines, and we used two different types of table partitioning. We did key partitioning and list partitioning. And we had to do a significant amount of aggregation, denormalization, and indexing in order to make the database perform well enough to serve up almost instantaneously dashboard widgets and reports. So our design methodology was a star schema with many aggregate tables. So the high fact table to dimension table ratio is because we had a lot of aggregate fact tables. So we had about 20 fact tables, but most of those were aggregate fact tables. We had 30 plus dimension tables. We didn't denormalize the dimensions, so that's one of the reasons why the dimension tables are a little bit smaller number than you might expect.
How big were those fact tables? How much time I think that you had?
So I'd say when we handed off the project, it had been running a couple of months, and they had 800 million. The largest table was 800 million rows. That was not a table that was directly queried by a dashboard widget or report. That was the base, what we call the base grade fact table in their system. And after that, we had year roll-ups. We had roll-up by boat type, by years. We had a significant number of aggregate tables that they actually developed reports against. So the different types of partitioning were key and list. We used the list partitioning in the stage tables. So we had data from two different business units coming in. One was Boats.com, one was Yachtworld. We didn't want dependencies between the two. We wanted to feel the load independently, even though we're using the same tables. So what that meant is at some time, after we finished staging data, for example, from Boats.com, we weren't able to truncate that table because we used common stage tables. And when we tried to delete data, 100 million rows or more, using the delete from command, we found it was extremely slow. Since we couldn't truncate, we decided to use list partitioning. So we could partition by business unit, and we could drop the partition on the stage tables and then rebuild the partition. And that was instantaneous. So it's basically the data was just gone within immediately. As soon as the drop partition command was issued, the data was gone. Rebuild the partition, and we could start loading again without impacting the performance of another business unit that would be loading at the same time. So for the fact tables, we had to overcome file size limitations for some of the fact tables. And that's why we initially went out with just a key partitioning. But the partitioning column was a smart column in a year-month format. So we talked about transitioning to a range partition for that to help us with the queries. But as far as I know, they haven't done that yet. It was good enough to overcome the file size limitations. So a little bit about how we got data in and out of MySQL 5.1. We used Pentaho data integration 3.1 for all data movement. So extracting data from Oracle and MySQL in the files and loading stage tables, as well as the loading from the stage tables to the star schema. We used Pentaho data integration. It allowed us to create a very modular load environment. So we had one parent job, and under that parent job, many child jobs. And so if one child job failed, we could rerun just that piece. It was very nested and very easy to run individual jobs under that parent job. Overall, we found PEI to have a great integration with MySQL, Oracle, and any data files that we have. that were thrown at us, including Excel spreadsheets, commas limited, didn't matter. And on the presentation side, we used Pentile reporting and dashboards. We used Pentile reporting 1.6, that was GA at the time, and Design Studio and Report Designer. And we created a fairly complex email burst solution. So they wanted to burst out this data to external subscribers via email with a PDF attachment. We were able to do that. So a single PDF had about 13 or 14 reports embedded in that one document. And we also built Pentile dashboards using version 1.6 that utilized dashboard widgets and drill reports. And that was for one particular boat manufacturer that wanted self-service data rather than to get a burst report once a month. That's it. Those are the 3 areas that I touched on. Questions? Sure.
In that example, did you have users that has staging database rows that were...
No, they never wanted to access the staging database. I mean, the staging database pretty much wasn't persistent. We had to deal with a lot of data. So as soon as we finished loading a day's web logs, we dropped that data. So it was rolling, so it would have been of much use to them at all. It was much faster. Yes, go ahead.
Do you have any performance issues?
Yeah, I think that, if we encountered a performance issue, we couldn't go anywhere with memory or any other problem. We just created another aggregate table. So we ended up having a significant number of aggregate tables. So in performance, the users wanted these to perform extremely quickly. People have gotten spoiled by doing a Google search and data comes back immediately, right? So they want data to flash onto their screen and click. The days of running reports overnight, those are gone. People want data right away. So overcoming performance was basically solved by creating aggregate tables.
So, what was the typical size of those?
We probably try to keep them under 100,000 rows for the dashboards especially, because the dashboard has to flash out. So but it could run. I think as long as it was under 1 million rows, it was compact, fact table, you didn't really have a problem. So reasonable performance. We used MyISAM. Memory table for a memory engine for a couple of lookups, so just part of the load process. It wasn't anything that queried. No one queried against any memory tables.
For that project, we were putting data on the cloud. Were there any issues you encountered, like running the MySQL in the cloud or the NetApp on the cloud?
I didn't encounter any issues, not really, because it was pretty similar to if you're comfortable using a Linux box, in your own environment, it's very similar for the way we used it. One thing I can say is that when you turn off an instance, it's gone forever. We spent some time building an instance. We thought, we'll turn it off and turn it back on in the morning. And then when we came back, turn it back on again, it's gone. So you start from square one again. So you got to make sure you create an AMI from it so that you can turn that back on again. Because when you turn it off, it's gone forever. We thought we could save money by turning them off and then putting them back on again. You pay by the amount of time.
So running all of the MySQL and the Java components at the same time?
Yeah, same
One
small.
AMI?
Yeah. But obviously you could split them easily. But in terms of the runtime, we kept it very simple. We didn't do any clustering of MySQL, which you would normally do, right? So in case you had a calamity, you wouldn't lose all your data. We did do backups, but we didn't do any failover.
This was using local storage or
We used the local storage up, and we used buckets, of course, to transfer data in and out. And that's why we're using the S3 command and S3 sync to sync data with the buckets. But like backups, we take a backup and push it into the bucket, try to keep as little data as possible on the server itself.
So to use the local storage, when the AMI is gone, you want to get it.
Yeah. That's why you want to take backups and put them into your bucket, because then it's pretty safe. When you turn off an MySQL backup.
And then when you build the AMI also, you actually save the image on the server and then come back tomorrow.
Yeah, we can do that. You can turn it on from the dashboard, from Amazon's dashboard. You can create as many servers as you want from that one AMI.
Is your Pantano run on S3 as well?
Yeah, it'll run on any server that's running Java. So if you're running a server in the cloud with Java, you can run Pantano.
So yours run on
This one is not. This one's running on a server, but if I talk about needing to transfer it to the cloud, so we don't have to run the server all the time. It'll be easy to do. It's not any harder to use a server in the data cloud than it is to use a server in your data center. Use SSH, FTP, everything is exactly the same. Except that you can turn it on and off, and you can clone 100 of them, in seconds or immediately if you wanted to, instead of having to call Dell or whomever, order the servers, have the servers come. Well, the load window was just a couple of hours. So after we finished the load, then we could drop the stage tables. But we couldn't. Well, we weren't really dropping the tables. We were either truncating them if they weren't shared business units, or we were dropping the partition. So the table's still live. Still, the other partitions you can still query. When you drop that one partition, it's gone. But you could be loading the other partitions at the same time. Any questions?
Your experience when you compare Pantano experience commercial BI?
If you're talking about the ETL side of things,
Yeah, but our components, for example, you use the PDI a lot.
right. Before using PDI, I used Informatica for about 10 years. And I still have projects in Informatica, actually. So I've used Oracle Warehouse Builder. And I would say that Pantano data integration, PDI, is competitive with those. There's certain things you can do better with PDI. There's certain things that Informatica does better. I mean, Informatica is easy, very easy to use. It's an extremely mature tool that you barely even need to know SQL to use it. You probably don't even have to use it basically. I think you need a little bit more skill to use PDI, but still it's not particularly difficult to use. So I'd be comfortable using either of those tools on most projects that I've done in the past.
So I'm saying like how does it affect tax?
I don't know. I've not used Talent. I looked at Talent about 3 or 4 years ago. No, maybe it wasn't 3 or 4 years ago. Maybe 2 or 3 years ago. And it was more of a code generator. I think it was generating Perl, I think, behind the scenes. And I wanted an engine-based approach for our project, so that's why I chose that. I think that it's gotten a lot better. I've heard a lot of good things about Talent, but I haven't used it myself. Any questions? Sure. If you're going to compare Pantano, the presentation layer, to say a Commons or a business object, it takes a little bit more sophistication to use Pantano. So if you have a business user that's used to dragging and dropping and having things perfect, Pantano's almost there. In the version 3.0, which has just come out, they have a lot of that functionality now built in. You can build dashboards without having to write JSP pages. You can create report prompts, so if you want to prompt your report user before the report runs. That's supposed to be a lot easier to do now in version 3. But it has been a steeper learning curve for Pantano, the presentation server. But it has improved greatly. And version 3.0, which just came out, I haven't had a chance to play with it yet. And that's supposed to be a lot more business user friendly nowadays. But from a database performance perspective, I mean, at the end of the day, it generates SQL. And if your database is designed well, I think that you won't have too many problems. Any questions? Thank you very much for attending.